The topic of our panel discussion today is very simple. It's like data, big data and data science in production. So let's remember like few years ago, a lot of hype around big data and a lot of talks, but now like such kind of hype is moving like in blockchain space, I think. And in big data and data science space, from my point of view, we have a time for production, right? And like challenges which connected with production. So my first question will be like, do you agree with that, now is time for production? And second, like maybe from your experience, what's kind of real problems, business problems you already solve in production using like big data and data science?
Hello. So, very good question. So the first thing I'm going to do is refer to the Google's engineering standards. They've published it online. And one of the first things they mention for any engineering problem or data science problem is to ship a solution that's quick and easy first. Make sure you ship something pragmatic, very practical, but it doesn't need to be complicated. Ship it out and try to start learning about what things you need to track. Because as you're trying to understand what is the measure of success for a business problem, a practical problem that's out in production, you need to make sure you're tracking the right things. And it's never going to be perfect. So get that process started earlier on, and then start deploying different models to see how they compare. And that is a perspective which is very crucial, and I perfectly, completely agree with that. There are, of course, other challenges like scalability of a solution and so on. So that would be my one key suggestion.
Cool. Yeah, that's a good one. For me, the way I see things as I navigate the industry is, I think it is actually time for production, but at least in the scene in London, I still don't see the amount of algorithms that should go to production in production. And there are two reasons or two sides, and he actually covered one in his presentation, which is the technical side. If your company is not technically ready to productionize algorithms, if the platform, if you, for example, have 20 data centers, who knows where, the data is dispersed, it's not good quality, there's no point in bringing a data science team. You're going to end up frustrated, leaving in 3 or 4 months. So that is one side. You need to get your company technically ready. But for me, lately, the most important one is the cultural one. You need to get the culture of the company ready to ingest algorithms. Technically, this is 2018. We know algorithms work. We know that for ages now, right? So, for example, in my case, I can tell you that in the industry like insurance, where you fight with the business, with the actuaries, etc., that they don't want to move away from traditional methods. The challenge is not technical. Technically, we're ready. It's mental, right? Or it's cultural. So I think for me, there are two roads, two venues to attack in a company. And data scientists, machine learning engineers, engineers of any kind, they need to be aware of those, and they need to address both. One is the cultural transformation, and the other one is the technological transformation. And he actually covered one of those very well in his presentation. So I think time for you.
Hey, yeah. In general, I agree that honeymoon is over, and for production, it's a little bit ambiguous thing that for different people it means different things. I guess that, in my opinion, everything starts with people, especially with business people. Yeah, and I would agree that there is a cultural thing, there is a business thing. Yeah, if your company considers itself as an AI-first company, this is like the first step to go to production. So if you consider like machine learning as a side research, you will never get there. So everything starts with people, especially with top management people with chief people, and everything else is the rest. Like technology goes after that, and yeah, that's my short answer.
Okay. And you communicate a lot with the business, right? So what's their expectation on big data and data science? What's the critical factors from business, yeah, that to make data science and big data projects successful?
So I would say that business is not well educated yet, and of course it is expected to be a magic from data science and machine learning, and our goal as a community is to educate business so they understand it, business and product managers, how to build a real product from and consider capabilities that can be added by machine learning into their products. So it's a tough thing. For every company, I guess they have their own story about the monetization and productization of our algorithms and building like end-to-end solutions there. So that's my general answer. I guess you guys have better stories about that.
I'm not sure if better. I saw once a presentation where this guy, I can't remember the name of the company, but he was saying you should only hire data scientists if they're going to make you money or save money. Normally, I find that business people, they react better at the beginning if you're going to save money, if you're going to cut costs. But in reality, for me, so he mentioned the word education, and I think this is a bi-directional process. I think you need to also educate your data scientists in a sense. You know, you don't need to let them dive into the beauty of the problem just because it's a problem. There has to be a business purpose, and the same way it happens on the business side, right? They need to understand that there is the solution, there is a journey. For example, I'll give you an example, right? One of the managers in my company said, let's see if the algorithm works, and then if it works, we'll put it in production, right? That's not the way it works. It's the other way around, right? Let's get the systems ready, and one or the other algorithm will work. So that shows that he doesn't really understand, right? So it's my job to get him to understand what we can do, but it's also my job to understand why he said that, why he believes that I first need to prove all this value, and why can I actually address this conversation with him. Why can I, for example, you know, business people, they like numbers, and it kind of makes sense. They want to know that the company is going to grow, and they want to see, you know, expected growth and revenue, and my numbers have to be sensible. So I always say one sentence, which is, I don't like PowerPoint because there is a lot of power and no point, but I believe that, you know, there is some use in PowerPoint, and very simple, straight to the point presentations where they can see the value that we bring, and we can understand the value that they want.
So on this point, there was one key learning I learned the hard way, which is as a data scientist, I was again asked to design some metrics for a purpose. Business asked me to design a metric, okay. So I went away, designed this metric, came back to them, and gave it to them. Now, as they were trying to think about how to use the metric, they realized they need another metric. So it was one where it was customer lifetime value and how do we use it and so on. And when we start thinking about it, we realize we need multi-touch solved first. And that's another example. So even in that education process, I think what you need to remember is that you're in uncharted territories, in that we are, you know, we are exploring new heights with the business. So the best thing to do is work closely with them and be very transparent to show progress. Because even if they say, I want A, as you're exploring further, you'll realize it's supposed to be a 0.2386 or something very specific.
So just speaking on the same language, right?
Yeah. So, and sometimes they don't know. They think they need one thing. But one of the key components of data science is making sure, are they asking for something specific, but what's the problem? Try to identify what the problem they're trying to solve. Don't give them what they ask necessarily. So trying to understand the problem itself is very core. So try to talk to them, work with them, design even an MVP, but be very transparent. And as you're working with them, you'll realize that it uncovers other areas. And that's the core problem they need to solve. So that is an essential component. But again, as Javier said, it's, again, data science is not a liberty to say, here's funding and you can go do research. It's where is the business impact? That's the perspective that you always should put first. Here's an approach I can take. I can try it out. What's the impact going to be on the business? Here's another approach I can take, which is longer, more accurate, but does the business care that that model's difference is going to make any, is that going to make any difference to the business? If it's from 80 to 85% difference. You need to think about that.
Okay, cool. And
let me just add just one quick thing. So in Simply Business, we actually found that that was one of the problems. There was a misunderstanding between the business and the team. So when we found this, there is now a web of meetings. If you wonder how we solve this, I have the same problem. So there is a web of meetings that I head the team, so I mostly go to most of these meetings, but gradually all the rest of the teams also share the meetings. And I had one data scientist told me, I hate people, and I prefer computers. And at the end of the day, I told her, you work with people. So little by little, engineers, data scientists, every different species in the team, they gradually share these meetings. So for example, it is not, at the beginning, it's not comfortable because you invest, not waste, a lot of time. But I spend probably these days half of my week in meetings with the business units, with all product teams. And that is proven to work really well so far.
Okay, cool. And I think you agree with me that any big data science project, it's not like simple stuff. And you already mentioned some challenges, but what is your hit pride of pain? What's the most challenges, maybe top 3 that you face it in your data project, and how you solve it?
Okay, let's think. Yeah, let's keep cultural challenges. Yeah, so we've talked a lot, and of course, we're already talking about a data science project as a general product features. Yeah, so you have engineers, you have machine learning engineers, you have QA, you have ops, you have all other product managers. So in general, when we start talking about productization, it's the same as all the rest of the world. Yeah, nothing differs. Specifically about open questions, open challenges in the industry that we faced, for example, is of course a question of latency, performance of particular machine learning models, and that data-heavy applications that process a lot of data, and we need a particular latency and throughput to process. And especially when you are moving data from one system to another, it's already a bottleneck of moving even data between different between memory and CPU and GPU. It's all about moving data and optimizing this. Even micro data flows is a big deal, because you have, for example, pandas frames, then you have Spark frames. In order to transform data from one frame to another, physically it's the same array, yeah. But in order to when you transform it from one thing to another, you waste your time, waste your CPU cycle, you waste your memory. And if you're building a data-intensive applications, you start caring even about such a low thing, things of data movements between data structures. So I would say, and the profiling thing that Roman has shown on the last slide was really perfect, and thinking about latency, thinking about all that low-level stuff, is a very nice challenge to solve. Then the problem of productivity in general. So how quickly we can iterate, how quickly we can deliver things, and what tools do we need to help data scientists and machine learning engineers to experiment easier, faster, and actually community is supporting us in that. So a lot of tools, a lot of new projects. This is amazing, and the APIs become higher level. You don't need to be worried about some low level stuff. And yeah, that's like a general trend. And let me finish, and I will follow up later probably with some use cases.
For me, I'll say, I'll summarize. Technically, so culturally, I've already said it. Technically, is the development environment. It's building a proper developing environment. Because normally, when companies hire data scientists, we want to play with data. We want to get access to the data and start running the algorithms. And normally they don't have a developing environment. They have the development environment. They have the live environment that you can mess with if you have bad practices. So for example, I can tell you the first time they gave me the instances, or I set the instances in the live environment, I set them myself. I gave myself pseudo permissions. So imagine the amount of things I could do there with live data. And this is really bad practices, right? So, but they don't really understand that we need, or they don't really understand. There is not a general understanding that we need a development environment that also has access to live data. So, for example, in our case, we are now moving all the data in the live environment to an S3 bucket in the form of Parquet files, and it took us months to convince everyone to do this process. And that is technically perhaps it would be my biggest complaint or the biggest challenge that I faced in almost every single company, having an environment where I can freely explore, but mimics as much as possible the production environment.
So you said the top three key things. One key thing we already spoke about, which was structuring and the problem space. So because I've been working in the marketing side, or rather what is also popular term growth side of the business, talking to marketing teams or more non-technical teams to structure the business problem into a mathematical problem is a challenge. And that's why working quite closely with your end customers is quite key. The other two, I would say, the second one is explaining a machine learning solution to your customers. Why does the model say A, not B? Why does it do that? And you trying to say something like, I don't know, because it's deep learning and it's hard to see what's going on inside, is not good enough. And there are actually a lot of papers, particularly in the marketing side as well, where they've recommended very logical, very sound approaches, but have not been adopted. Why? Because the business went, they don't want to adopt a black box solution. Making that black box transparent is a very core job of the data scientist. It's a responsibility you have. So that is the second one I'd say. And thirdly, especially anyone entering into data science or already there, particularly working with AI, there is a lot of pressure to build something amazing, something that's magical. So that's a lot of pressure. And the thing is, that pressure quite often comes from the data scientists themselves. Sometimes it's going from 0 to 100%. You can go from 0 to 50 and then go and try and make that better. So even if it's a simple solution, try and see if you can implement it. If it's something you can explain to the business, that is going to get adopted quite well. So have to have that balance. So if you're wondering, it's not that good enough. And I think someone I'm going to pick on is Javier. In his presentation, he was doing a lot of things. And he's like, yeah, but that stuff is very simple. And it is simple.
Simple business.
Exactly. Simple business, exactly. Because it's simple, but effective. And that is really important. And that's what business looks for. So don't be afraid to try things, as long as you can explain it, even if it's not magic.
Have more to say?
Yeah. I was just switching that context. Yeah, a little bit long. Just a couple of examples from yesterday, from a week ago. Of course, they are not showstoppers. It's not the most painful problems, but in general, just as an example, for example, the tooling. I keep talking about tooling, and a lot of great products appear in the market. Amazon SageMaker, for example, and I asked the data scientist. He had a problem. He had to experiment with the data, but his data didn't fit his laptop. We saved it to S3, of course, and okay, let's go ahead and set up SageMaker to run some queries against that. All of a sudden, SageMaker had TensorFlow 1.4, which is absolute. We have 1.7 already, and data scientist had to build a new Docker container. He had to have a knowledge about Docker container. He had to learn an Amazon API, how to bring your own runtime to Amazon. So even having such a great tool, before even starting experimenting, you would need a whole set of skills and a whole set of actions to perform in order to set up an environment for you. So that's a pretty trivial problem, but it shows the trend that sometimes we waste our time by doing such a basic things. Also, there is some myth that we have 9 algorithms that can solve 99% of our problems in machine learning in general. Yes, of course, very often simple algorithms work better than complex algorithms. I wouldn't argue with that. But all of a sudden, in my experience, we end up building something from scratch from the recent papers, even for solving not a trivial, it seems to be trivial, and you can build any classifier with well-known algorithms, but I would say that not all of the algorithms have been implemented yet, and there will be more, and you shouldn't believe in that. Okay, I have to know random forest and logistics regression, and that's it. So there will be more, and when you will face a real problem, you will need to implement something from scratch on TensorFlow or on PyTorch from the low level. Yeah, that's my insight and my experience.
Well, hopefully, if you call yourself a data scientist, you'll know more than a logistic regression and a random forest, but you will know them. If not, don't call yourself a data scientist.
Okay. So guys, I think you remember this landscape, big data landscape pictures, which fill it with a lot of tools, right? And now we have a dense, super scalable, reliable platforms which solve every big data problems. So how do you choose the right tools from this crazy landscape for your project? And it becomes obsolete every week. So every week publish new versions and so on, and you need to integrate with some old solutions. So how do you solve such kind of problems?
Well, I'll go first. I choose the right tools by choosing the right team. So I make sure I hire the right people that know a lot, or that they are eager to go home and experiment and to try new packages, to test whether they're ready for production. So, of course, when you're going to go to production, you want the package to be robust enough. But for me, the answer is as simple as that. I mean, you hire a bunch of expeditive people that will go there and try stuff. They come back to the company, they tell you, I've tried this and that. Then we work with the engineers, see if it's ready to production. And of course, if we work in Python, in Scala, as long as the version is for example, I love PyTorch, but it's still not production ready. So whenever it's production ready, I will use it. But yeah, that's my short answer.
For me, I like to choose tools that can adapt to medium-sized data and big data and can scale all the way. So like Apache Spark, TensorFlow, but any of those you do, you have to choose it in a way that you can scale it. You can make it into a distributed algorithm, and that's, again, a really tough space to work in. But especially whether you're a data scientist doing this implementation yourself or working with, again, engineers and a team of engineers, make their life easy again. Try to use a solution that they can work with and don't need to rewrite the whole thing again. So trying to make sure you are in sync with your production stack is quite key. That's what I would think. So yeah, that's my simple example, and I'm a huge fan of Apache Spark. Versions-wise, I stick to whatever is a stable version that works in production until I really need to upgrade. In that, I'll test it on the next version, the next release, and if it looks stable, then I use it in production. But whatever is adopted in production will be used internally in any of the local stacks. Nothing new and fancy, because if you use something new and fancy and it's not adaptable because some feature in production is limited only to that old package, it's a huge problem, and then you need to rewrite. And I kind of say the same thing even for languages. There's so many languages to use, but even if you're someone who really likes Scala and implementing it, but your production stack is completely in Python, and your production team knows only Python, then they need to rewrite the whole thing. And that's not very nice. And that is really siloing yourself in a company. So you have to keep your company's perspective first.
I would absolutely agree that people are much more important than tools, and having the right people is the first step to decide about tools. I guess all those landscapes are for big enterprises that in order to solve any problem, they go to a magazine and wanna buy something, buy yet another. Can I buy a couple of kilograms of big data or AI or something else? So bringing yet another vendor from that landscape is, of course, is not the way to go. And in my opinion, having pretty modular design, when you can easily replace any obsolete technology or tool or framework, is probably like evolution, some evolution approach, of any project, and especially in such a complex and pretty wild space as machine learning and AI nowadays.
Cool. And last question will be a lot of like futuristic question about future. So now a lot of like predictions, like that all work will be doing by robots sometimes, or for example this Cambridge Analytica case that like mind of the people is controlled by big data, or this for example China case that every people like has rating based on some activities and so on. So in which cases do you believe personally? So what is happening with big data in data science nearest future?
Okay, I guess we need a bottle of wine to answer this
in
question.
Few hours.
This question. Okay, we can continue after an after party there. So I'm a bit skeptical about all that like futuristic things. So the hype will be over, and of course it will become a commodity, and maybe it's not commodity, of course, but it will become a commodity. And so talking about robots, it's even in a early stages right now. All that reinforcement learnings, they have like tons of problems. It's not solved in academia yet. Nobody will be replaced. We will at least our community we will have jobs for our life. So yeah. Of course, that talking about like it's a well-known thought that the ability to work with AI and complement AI is something we will expect in the future. That AI will not replace people, and people will complement it, or AI will complement us. So it's obvious we already are supplemented by our devices, our smartphones, and internet. So there won't be any revolution. I wouldn't say it's revolution. It's evolution. Yeah.
For me, the way I see it, I see it in two ways. There was a very nice article in Medium, actually, by Michael Jordan, not the player, but the famous AI computer scientist and statistician researcher. And he explains in the paper why the AI revolution hasn't happened yet, and it won't happen for a while. But one easy way to explain it, or one easy way to put it forward, is 99.9% of the chatbots out there are an infinite collection of rules. They have nothing to do with deep learning or anything like this. So we are far away from getting a chatbot that actually understands context and things like this. So this is on one hand. We are far away from an AI revolution. And the second one is, do we remember where business analysis or BI was something amazing, and now it's something absolutely normal, or ETL, right? When it was the beginning, and now it's something normal. So I always use the word normalize. I dream of a day where machine learning is normal, period, or artificial intelligence is normal. But in reality, then if we go to the extreme, and if we think of automatic cars or machines helping doctors, why this shouldn't happen? I mean, this should happen, and I hope, for example, if you drive the underground in London, I hope one day you can aspire to have a better job, with all my respects, spending 8 or 9 hours a day underground. So for me, I only see positive aspects, but there is a process of education. You need to train people that won't be able to do these jobs, like driving a car or a bus or a truck. But regarding to the hype, the bottom line is that the hype is far from happening. We're not there yet.
So, funnily enough, I asked the same question to Dr. Stuart Russell, who worked with Peter Norvig. So he's like one of the fathers of machine learning, and I had to read this big fat book for machine learning all about it. So when I met him, he was giving a lecture on inverse reinforcement learning, which is, I want a robot to get me a glass of water now. Say, get me a glass of water, doesn't mean go from here to there and kill anyone on the way or run them over and get me that glass of water. No, it means learn from the people around you, stop when needed, act sociable, and go around them to get that glass of water. People are more important than water. So there, again, that was really interesting, because that's the way AI is going to scale. It needs to learn from us rather than us keep programming. But with that comes a responsibility. It's going to learn the good and the bad. So if there's a lot of bad behavior, stealing, any of that, it's going to propagate the same thing. And then it's going to understand the value of humans eventually. So we need to make sure our morals are right. Another example is one of the Twitter bots that went out, which went and started self-learning and became one of the most offensive Twitter accounts. And this was AI. And it's not the AI's fault. With great power comes responsibility, and sadly, it's given to us. So it's learning the good and that bad. So we need to make sure what we put out there is a lot of good. and a lot of responsible behavior, and again, and also a sense of policy. I say policy, but in a good way, because even if you think about blockchain, in that space, there's so many different versions of digital currency now. Nothing is going anywhere until there is structure and some sense of policy. And that concept of blockchain can really, again, scale and be implemented in many different spaces, but to give users more power and such, unless you use it for the wrong thing. So the question is, are we being good or bad? And you could see the same thing about the level of power, like you said, about printing press. Before, books used to be about $2,000 because everything had to be written down, and that's it. And there would be errors and everything, but that's it. And that used to be a very expensive process. And now that printing is possible, people could have easily taken those pamphlets, put fake news, and put it into people's houses, spreading fake news. And people could go, oh, it was on printed paper, so this must be news. So whether it's that or in a digital form that can reach billions, it's about, are you working ethically as a business? And that is a core concept to make sure.
Okay, thanks. And now your time. So we have, I think, time for 5 questions, and we have 5 books. Raise your hands.
Is it on? Yeah. There is one question for me as a beginner and maybe someone in here. Can you give us an example how to learn some things? Where can we learn it? And maybe some words of wisdom how to become a good specialist in field of data science. Thank you.
Wow, how to learn something. So today, 2 people asked me, how do I cope with publishing, with advising startups, and with a job, with having a wife that is somewhere there. And so how to learn something? My answer to that would be with passion. I really love what I do. For me, my job is not 8 hours a day. So as I said, I come home and I keep exploring, I keep diving. I'm a member of I don't know how many blog posts and machine learning sites. And how to pick something, there is one reality for me that it is you can't learn anything. So for my words of wisdom for you, just take it or leave it, is surround yourself by clever people, and if possible, more clever than you, and then you learn a lot of things.
Yeah, actually, that's a pretty interesting side effect of that hype, that people started to learning something, started to learn math, algebra, theory, and so on. That's a great. So, yeah, in general, you need to just fall in love with data, with just hands-on programming. That's it. And the rest will come. Just you will not even realize that.
Something to say?
I would say start working with real-world examples. I think that's the biggest gap that has even been in schools, in universities. You go learn all this theory. Now you could do an entire PhD on data science and come out to business and not feel like you're ready at all. So what you should do is work with a real problem. I think someone asked me earlier about the same thing with multi-touch, how to work with that. And I said, try and get some data where you see that problem, whether it's the Oscars data or, say, football data. If you're trying to understand how multi-touch, for example, works, try to understand who scores a goal in a football game, and does the credit go entirely to the person who scores it, or every single person who touched the goal, or even the people around them. So start with a real problem. And I think that's why spaces like Kaggle which is machine learning online competition space, has become so popular because the first thing what you're trying to do is do image recognition of people's handwritings or predicting if people survived or not in the Titanic. And that is the key thing. Make it real. It's not just algebra, it's not just statistics, make it real.
Cool.
Thank you for your lections, for your presentations today. I have a question. You said a couple times that business should understand data engineering, data science. How to convince business that they need to do this? Because right now, what I'm hearing on my job that we must understand, like data engineers, data science must understand clients, but we don't work directly with clients. We're working like with our business, like accounts managers, accounts representative, and etc. So, and this is the huge problem for us because we can speak with client, but we have to understand him. So, how to convince business that they need to understand data science? Thank you.
Just give them a free pass to this conference. And they will like it. That's it.
Okay, maybe a more practical question. If your company is hiring data scientists that they believe they are not ready to face the business or to face the clients, then there is either a problem on the data science side or a problem on your company. So there is no way, if you want data science to be extended and integrated in your company, there is no way of doing it, avoiding presenting your data scientists to the clients or to the business. Another issue is, of course, whether the data scientists are able to talk the business. But believe me, for the business to learn machine learning is a lot harder than for data scientists to learn the business. But so my advice would be, there is a training process. So, for example, at Simply Business, the first interaction between some data scientists and the business was not very good. Very long explanations, very detailed explanations. But again, you know, it's a learning process. They need to be patient enough so that at the end of the day, data scientists will be succinct, come to the point, numbers, figures, whatever it is that you want to learn, and also on the business side. But coming back, so I am very, very clear. If your company doesn't think that you guys need to see the clients, then there is a problem in a strategy that you guys need to solve.
So I've seen this in a few companies where they're trying to move away from the concepts of BI, business intelligence, and more towards data science. And the business doesn't know, like, the difference. So they might go, hey, I need you to extract some data and build dashboards. Can you still do that? You're a data scientist. You should still be able to do that. It's like, yes, but for the same time, I could build that an algorithm that gives you some forecasts on that dashboard that can sustain you for 6 months, at least. And that's the difference. And it is definitely an education process, and it's not easy. So there are, again, many blogs that have come out, really good ones, about trying to explain what data science is and the power of data science. And I would definitely say, don't try to reinvent the wheel. Find that content and share it with them to try and explain this is what's happening. And the core thing as a company, they have to be ready to be data-driven. If the company says, I want to do this because I think this is the right thing, where is the data to support it? And if they cannot prove that, that's where they know there's a gap. And the idea, again, is not just data analysis. That's the kind of things that, whether it's a PO, whether it is a team lead, they need to be able to do that themselves. And they need data scientists to make these solutions scalable and automated for hopefully a good few months to save them the trouble. And that education process, I agree, should come to a fair extent from the data scientists themselves as well. So they need to communicate that process.
Next.
Have you ever developed some new solution that was never discovered before? Like some state-of-the-art model on something like this? And what was your feeling when someone discovered this after? Is it clear?
Yeah, he said, if I've developed solutions that never saw the light, that were never to production?
Solution that was never published. Like
Never published?
Yes.
Yeah, yeah. I mean, as I said, I don't know if I mentioned it yesterday or today in the presentation. Cloudera published this research where they say that over 80% of the algorithms that data science teams do in the UK, they don't see the light. They don't go to production. They're never published. So I'm part of this statistic. So I'm happy to say that at least in my case, it's not 8 out of 10, but it's not also 5 out of 10. So many of the algorithms that I've done, they haven't seen the light. And I've learned a lot. To be honest, I've learned more about the many projects that I've done that have failed. And please don't think that I'm a crappy data scientist, or maybe I am, but I've failed many times. And I've learned a lot. I've learned a lot on how to communicate the solution, how to design the strategy. So, of course, the advice would be fail fast. The faster you fail, the faster you can move on. And there's an entire book on failing fast. There is no one on succeeding fast. But yeah, so to answer your question, yes, many algorithms I've done, they haven't gone live. The reasons are mostly, in the main cases, are a lack of a strategy. So they asked for an algorithm that they didn't need. They asked for an algorithm that we were not ready to productionize, etc., etc. And then you learn. You know, now I do this thing that I call business-driven data science. I make sure that through the strategy, the algorithm is used. And I would say strategy is everything. If you design a good strategy, you should start a project knowing that it will go to production.
As you know, there is no any product development right now without feature flags. Do you use feature flags? Just to, even in order to introduce a minor feature in your product, you have to test it before. I mean, you have to test your assumptions that it will work well and the users will like it. So, and even in like a regular product development, more than half of features do not pass a feature flag tests. Yeah, so they will never see live. The same thing with machine learning features, even if it's more very sophisticated stuff that and users will not like it. Yeah, that may happen, and that's expectable with any business, any features, and there's nothing special about that. Talking about the research phase, if a research phase didn't hit like a level of even considered to be productionized, yes, of course, it's a funnel, yeah, from the research to production, and just a few of the end-to-end solutions will see end users. That's true.
So there are two ways to think about this. One is you have a state-of-the-art solution that never sees the light of day because your company is not planning on using it. And the other is you've tried it and it's not the ideal algorithm, or it's not having the right desired results in your product. But the one thing to remember is that you still have publications. And the idea around publications and papers is that you share what's happening in the community, so you learn from each other. So even if it's a good solution and you've tested it and it didn't even work out, that is still a scientific process you've adopted. You made a theory, you designed a solution, you tested it, didn't work out, but it's a learning. It's still a learning. So try to get that out as a white paper or as an academic paper, so at least your peers and others can learn from that. And what you still have is a learning. So and the thing is, if everyone had exceptional solutions. The other book there's a book I'd recommend you to read by Nate Silver. Now I can't even remember the name. Signal and Noise, that's it. And he talks about how the average price of an innovation in the US in about 1980s to the millennium was increasing on an average because people were just trying to innovate and they kept having funding, but they weren't getting any useful innovations. It was all failure. To a point where it spiked, and then it started falling lower. Because at that point, you're actually doing your testing and your research properly, and you're using the information in your community to find the signal from the noise. So even if you're doing something that you don't think is ready for production, if it's academically valuable, try to publish it.
Thanks. Next.
How would you judge if this person is a good data scientist asking only 3 questions? Which these 3 questions will be from you?
Wow. Do you want to go first? I really don't know the answer to I never thought. Actually, it's a good question. That would shorten a lot my interviews. I don't know. Perhaps one of the first questions that I would ask would be about programming, even though it's not in this order, but something, a quick question around programming. The second question would be a problem-solving question. There wouldn't be anything in general. Okay, I'm going to not answer you this question by just saying what I could do. So the short answer, I don't know. I don't know which 3 questions would I answer. But what I can tell you is that in my interviews, I value far more the creative aspect than the coding aspect. I always ask for a minimum amount of programming skills, which, by the way, we code in Python and Scala, but I don't really care whether it's R or C++ or Java. I don't know. I think good technical people learn quickly. So I value more the creative aspect. So we either discuss papers or discuss algorithms. So I gave them a problem that applies to the company, and we sit with them over coffee or even some sweets in some cases. So yeah, that is. I try to design the way I spot good data scientists, and I'll give you an example now, is actually by asking them creative questions. And in my previous company, I hired this French kid, and I say kid because he was 21 years old, around to turn 22. No PhD, no nothing, which proves that you don't need a PhD to be a data scientist or machine learning or anything. So he came to the interview, and to any of my questions, he was answering with another question that made total sense. And after 15 minutes, I went out of the room and I said to the rest of the team, I want this guy. I mean, you guys can spend all the time in the world testing his Python, testing with whatever. He had no idea in Python. I actually asked him a problem, and he came back with some C++ that I have no clue of. So I saw and I thought, okay, it might be all right. But the guy was so genuine in asking me the right questions that he shows so much creativity that I hired him, and it took him a month to code in Python. So totally worth it. One of the best data scientists I've ever worked with.
I think that highlights a very core aspect, which is a data scientist doesn't just answer what they've been asked for. If the business says, I want you to build me a recommendation system that can recognize any kind of food, the task can't be to go and try and identify all types of food. If the data scientist just goes and tries to do that immediately, that's an issue. You have to ask questions to the business to figure out what they're trying to solve. Maybe they're trying to identify if it's a hot dog or not, and that's it. So maybe you don't need to solve for every type of food, hot dog or not hot dog, and that's it. So it's a simple thing. So you have to ask questions, core thing. Try to figure out what the problem is, not just try to build what they want. The other thing I would say is they need to think about how to measure success. The one thing you don't want to do is try to have a data scientist doing things for the sake of doing. Why do it this way in a new technology stack? Because it's fun. But what's the point? What are we trying to solve? So keeping that success measure in line is very essential. And thirdly, one thing that always kind of caveats is someone who doesn't explore the problem space, and you say, how do you solve trying to figure out, again, the food example. Okay. Deep learning. So your answer to this is you're going to build a network that's going to just analyze images and produce results? Yes. But you have like a whole team of marketing that needs to work with you and so on. Try to understand the problem. First of all, how many even images do you have? What kind of food do you need to categorize? What are the kind of image quality you have and so on? So exploring the problem space is really essential. And if a data scientist is not doing what is called EDA, which is exploratory data analysis, that is a problem because that needs to happen at the very beginning of the life cycle to understand what's going to be the ideal solution for your problem.
I'm sure you're going to have some tough questions for data scientists, right?
Not actually. That's a very personal stuff, and interviews in general are very personal. The same, like there are no 3 questions you're gonna ask if, to decide if it's your wife or not your wife. Yeah, so it's impossible. No, you have. If you so I think the question I would answer this way. You might want to. There is difference in hiring generalists and specialists. Yeah, and it's up to you to decide. If you need like a particular if you are playing chess and you need to particular people with particular skills filling those positions, and you're like that's one approach. I don't like it. Usually I would agree. So the personal thing goes first, then the level of curiosity, and even if we don't need a deep learning for this particular problem, just it was to ask about that, because you had to read this, you had to play with that, even if you didn't have that task in your task board. Yeah. So personal thing, level of curiosity, and some foundation background, who you are. Are you passionate about data, or are you passionate more about the system stuff, or are you passionate more about the business, or altogether? I haven't seen that yet, but it may happen. And then you just describe the problem you have. Everything starts with the problem you are trying to solve. And if engineer, data scientist, given his background and knowledge, is motivated to solve your problem, and you just discuss that problem, and you brainstorm about that problem, and try to solve it right on an interview to the certain level, and that's it. I am against such interviews when people have a list of questions and check marks against every answer, if it's correct or not. That's stupid, I guess.
And I just wanted to add, not to say that deep learning can't be the answer for an interview, totally could be. It's just you need to understand the problem space before diving into any solution. And making sure they understand that problem space is a core component.
Sorry we didn't answer. No 3 questions.
So cool. Now you know like questions to which you need to prepare. And last question. Sorry, this man was first.
Oh. Hi. There are many competitions between AI and human. And last competitions, we know about AI win and answered questions better than people, better than men. When we look to Facebook, we get technical support from chatbot, and this chatbot is very stupid. Why? What is your opinion? Why,
Lord, why?
Why? Why they are stupid? And what is contradiction between these two things?
Why chatbots are stupid? That is a very good question, and because yes, they are stupid, and the reason, well, most chatbots are stupid. The reason is called context specific. The reason is that up to date, it is really impossible to give context to a natural language processing algorithm. And I'll give you an example, right? This is an example that I'm going to steal from this person that I mentioned, Michael Jordan. So imagine that I invent a word. I'm going to say blah, the word blah, and I tell you, blah went home in 10 minutes, which was quite quick. You don't know what blah is, but you might think, okay, so blah might have legs, and it went home, and home might be far because it took only 10 minutes, but it got there. So suddenly, I just told you a new word that I've just invented, and then you build an abstraction of the word. That is impossible for any algorithm to do. And so far, this is actually a very, very complex problem that a lot of people is researching in top universities. And it's, today, it's not possible. So when you build chatbots, normally, they are really designed for a very specific context: finance, insurance, some kind of marketing in a site. And for example, the Ryanair's one, or as soon as you start asking more complex questions, they go nuts. They just, the answers make absolutely no sense. With all if there is someone here from IBM, I apologize beforehand. IBM's chatbot is awful, or at least it was. I don't know how it is now. IBM transcription tool is not really good because all these algorithms, well, all these tools, the algorithms behind are context specific, and context is still impossible to provide to an algorithm. NLP based.
Yeah, I would almost agree with everything you said. Yeah. And I also value that article. Recall that article from Michael Jordan, and that was great. So, and actually, it's back to the question about the business and about we need to have business that understands the limits of AI in that sense. So, Facebook could not build chatbot that is smart enough to answer, just to support users. And actually, the insight is that 99% of chatbots are just rule-based scripts. It's not an AI at all. So, of course, there is a level of machine learning that provides like spell correction and all that stuff. On top of that, but at the end of the day, it's rule-based. It's rule-based programs. All of a sudden, we are not there yet. Sorry.
Yes, a quick one. I went to a conference in London, and I was also part of a panel, and there were a lot of telecoms there, and I was there in the room, and it occurred to me to ask, if any of you has a chatbot that is not based on rules, please challenge me. No one raised their hand, and I said, okay. If any of you has a chatbot that are not SQL rules, so I'm going to go to Python or R or whatever, please challenge me. And only 2 guys raised their hand, meaning that all the other ones that were claiming they had chatbots, their chatbots were SQL. So this is the amount of AI, right? SQL and spreadsheets.
So, like they said, we're not ready for the Turing test yet. However, again, like I mentioned earlier, inverse reinforcement learning is one way where chatbots learn from us, or even AI learns from us and then starts scaling, because these kind of situations, every context is specific. But even having, like the example I mentioned before, where they had a bot that was learning from us, that was a Twitter bot, got into a lot of trouble. So businesses are actually better off with rules right now till they realize how to train the model on the right kind of data.
Yeah, let me add on a chatbot. If you can, I would try to explain a very simplistic way how chatbots are designed. Basically, it's trying to construct a SQL query. They have a knowledge base, and SQL query is select answer from knowledge base where the question is, and question is like whatever user has entered in a chat. So this is basically it, and the ability to build that query and to build like query and fix some errors or fix some spellings and understand that intent is just a basic thing. That's why it's not how to think about AI. Yeah, AI is it's a user interface. It's some machine learning part, and it's integration with other systems like database, like other subsystems, kind of automation around that. So actually, this is AI, even if it's just ends up in a simple query to Elasticsearch when you have answers to your questions, or if your final intent is to buy something, the query goes against your catalog of your products. You search. You basically, it's another form of searching something. Yeah, you search in Google. You search an answer in a chatbot. So that's tricky. But anyway, let's see where it goes. I wanted just to explain why it's not working, because if you will think about that as a knowledge-based database, you will get it.
I refuse to believe SQL is AI, by the way.
The other is also, like many of the topics we've been talking about here, the term feedback loop. They don't have, at least from the sounds of it, that they are not measuring what's the user's response to these chatbots, or they'd be learning. So again, having one of the key terms to be measure of success. If their measure of success is how many customers stop talking to the chatbot, that's wrong. Whether it's for good or bad, it's wrong. Are they happy with the service? Are they frustrated with the service? They need to actually have a proper feedback loop. And like they mentioned, if they're implementing it perhaps by SQL, they perhaps are not even ready for the feedback loop.
Cool, thanks. That's it. Please applause to our awesome speakers. It was really interesting and useful discussion.